In this lesson, we're going to learn about the parallelogram. So first thing is the definition of a parallelogram. So a parallelogram is a quadrilateral with two pairs of parallel sides, hence parallelogram. So the opposite sides are parallel, and there has to be two pairs, because if there's only one pair of parallel sides, well then by definition this would be a trapezoid. So a parallelogram is a trapezoid because it satisfies the definition of being a trapezoid, but in order to be a parallelogram, you have to have both pairs of opposite sides being parallel. So some other properties about parallelograms, these properties right here, 4 sides, 4 angles, the sum of the interior angles is 360, the sum of the exterior angles is 360. Those are all true for any quadrilateral. So since a parallelogram is a quadrilateral, all of those properties still hold true. And then if we look at the bottom here, we have some additional properties that are unique to parallelograms. So a parallelogram has both pairs of opposite sides parallel, which we just talked about. And remember, to mark parallel, you put the arrows. And then also both pairs of opposite sides are congruent. So you, again, both pairs have to be congruent. And then we also have opposite angles. So our opposite angles, so this angle and this angle, those are considered opposite angles. They're opposite each other. Remember that the same side interior angles, so this single arc and this double arc, are going to add to 180. And the reason why that's true is because if these lines are parallel, then you have same side supplementary interior angles. So those will always add to 180, which is really what this property here is saying. So consecutive angles or angles next to each other or in a row all mean consecutive. So these two angles are going to be supplementary, as well as if I were to draw in another pair of angles here, these are going to be supplementary, all because of parallel lines implying supplementary same side interior angles. And since you have both pairs of opposite sides parallel, you're going to have multiple pairs of consecutive angles that are going to be supplementary or adding to 180 degrees. So it's not just those ones. You could also say, I'm going to just redraw that. I just want you to make sure that you see in a parallelogram, it can also be the angles down here that are supplementary, because both pairs of sides are parallel. So then the other one that comes up a lot is the fact that in a parallelogram, the diagonals bisect each other. So this diagonal and this diagonal, they're bisecting each other, which means that they cut each other into two equal parts. So these two parts are equal to each other, but not necessarily equal to these two parts on the other diagonal. And then lastly, in a parallelogram, one diagonal will always create two triangles. So in this picture, triangle 1 is going to be congruent to triangle 2, and you could use your properties of a parallelogram to be able to prove that. I mean, the easiest one is just to think, well, if opposite sides are parallel, or not opposite sides parallel, if opposite sides are congruent, so if those two sides are congruent and these two sides are congruent, and I have the reflexive property, right away you can see by side, side, side that these two triangles have to be congruent. So that's the easiest way to kind of justify that property. So those are all properties of parallelograms. Lots of different things to remember, but most importantly, the definition of a parallelogram is opposite sides are parallel. Both pairs of opposite sides are parallel. So if we look at an example of how you could prove a parallelogram on the coordinate plane, you could use your different properties to do that, basically proving one of those unique properties for parallelogram. So proving one of these things would get you there. There's also some combinations of these that you can do, but most commonly, if you're trying to prove that you have a parallelogram on a graph, I'm going to circle this one, put a star by it, I'm going to highlight it. This is going to be your most common way to prove a parallelogram on a graph. Is it the only way? No, but if you think about it, it makes the most sense, because if you're trying to prove that opposite sides are parallel, well, that's going to give you a parallelogram. So what that really means is we need to show same slope. The other option here would be to show that you have both pairs of opposite sides congruent. So that would be same distance. You'd be using distance formula for that if you were going to do that. So you could do that on a graph, that's fine, but my recommendation is think about a parallelogram, opposite sides are parallel, so it'll just help you remember that. So you can do that. So those are two common properties for a parallelogram, which means you could prove it's a parallelogram using those properties. If you look at our, this should actually be number 3. These numbers are off. But number 3 here, a quadrilateral with the same pair of opposite sides, both parallel and congruent, is a parallelogram. So that's another option. It's basically kind of combining 1 and 2. But the main thing that you have to remember here is that it has to be the same pair of opposite sides, have to both be parallel and congruent. So this is definitely possible. So let me just kind of show you what that means. In a picture, I would have to, like, let's say I pick these two sides. I would have to show that those are both parallel and congruent. So you're kind of combining 1 and 2, but you're only doing it on one side, and therefore all of the other properties would automatically hold true. That one I wouldn't recommend on a graph, just because it's not as easy to remember, but you could do it. It's not wrong to do it. And then same thing with 4 and 5. These are other properties. Both pairs of opposite angles are congruent. That's one of our properties. You could prove that on a graph. That's not going to really work because there's no formula for finding an angle measure unless you have a right angle. So these will be more like when we get to our Euclidean proofs, like our statements and reasons type proofs. And then another option, though, is on a graph, you could show that the diagonals bisect each other. So for this one, this would mean that they have the same midpoint. So if you wanted to show this on a graph that the diagonals bisect each other, what you could do is you could find the midpoint of each of the diagonals and show that they're the same. Because if they bisect each other, it means that they have to intersect at each other's midpoint. That would be the easiest way. And then you don't really have to show that the distances on either side of those diagonals is the same, because if their midpoint's the same, well, then they're cutting each other in half through their midpoint. So those are all options, but like I said, I'm going to focus on number 1 using that because that's the definition of a parallelogram. So let's start by graphing this. So we have 3, 4, and -1, 3. Make sure you're labeling here. 1, 2, 3, 4, down 2. That is going to be so important with these that you're labeling. And then I'm going to use the first idea here. So what that means is I'm going to be using slope formula. So change in y's over change in x's, or rise over run. So if you wanted to count the slope, I'm fine with that. That's fine. Or use slope formula. Up to you. Make sure, though, that you are labeling everything. So let's say I start with the slope of AB. So it's our change in y's. So I'm subtracting the y's and then subtracting the x's in the same order. So I went right to left, so right to left. So this is going to give me -1 over -4, which is going to reduce to +1/4. You always want to make sure you're reducing these so that you're comparing them correctly. So that's the slope of AB. Let's go ahead and go down to CB and CD and find that slope, because then we can compare right away if they're parallel. So CD, I'm going to subtract the y's, so it's going to be -1 minus -2, and then 0 minus -4. So for this one, I'm going to have -1 plus 2, so it's going to be 1. On the bottom, it'll be 1/4, or 4, so 1/4. So I have the same slope, so this means that AB is parallel to CD. So I can mark that in my picture. Now I need to show that the opposite side. So right now, I can only say that this is a trapezoid because it has one pair of parallel sides. So I need to show that the other sides are parallel to guarantee that this is a parallelogram. So now I'm going to look at side BC. Again, making sure I'm labeling these slopes with their corresponding sides is so important so you know what they belong to. So -2 minus 3, and then -4 minus -1. So I have -5. This is going to give me -3 on the bottom. So this is going to be 5/3. And then the slope of the opposite side is going to be AD. So I have -1 minus 4 on top, and then 0 minus 3 on bottom. So -5 minus 3. So again, that's going to reduce to a positive 5/3. So this indicates to me that BC is parallel to AD. So I can mark those. Notice I'm doing double arrows because those are parallel to each other, not parallel to the other two sides. So therefore, I have both pairs of opposite sides are parallel, so I can say that I have a parallelogram. So I'm going to just write that over here. So I'm going to say quadrilateral ABCD is a parallelogram. So this is how I abbreviate parallelogram. I usually just use the parallel symbol, gram. So is a parallelogram because both pairs of opposite sides are parallel since they have the same slope. Equal slopes. So make sure for these coordinate proofs, you have to make sure you have a conclusion. And your conclusion should basically restate whatever you're trying to prove and then explain why does your work show what it is supposed to show. So I need to make sure that if I'm saying that both pairs of opposite sides are parallel, that's why it's a parallelogram. That's what my work's showing. That's what my statement needs to say. I can't say, oh, well, both pairs of opposite sides are congruent if I haven't shown that both pairs of opposite sides are congruent. So just make sure everything is matching, that your conclusion matches your work and your work matches your conclusion. So go ahead, get some key ideas written down from the video, and then using the properties from the previous page, try those examples or those check your understanding problems using the properties. So you don't have a proof, but try using the properties to answer some of those numerical problems, and we will talk about those in class tomorrow.